All right, today we're going to take what we learned on Friday and we're going to extend that. We're going to graph something that's just a little bit more complex than what we just dealt with. So in this case, we're taking 3 plus 1/2 the sine of x minus pi. And we're going to graph this guy. So tell me, what kind of translations and shifts and amplitude changes and so forth are we going to see with this particular function? Okay, absolutely to the right by pi. I agree with that 100%. So we're moving right pi. What else is it doing? Moving up 3, so it will no longer start at 0. And it will be shrunk. It will have an amplitude that's half as large as its normal. Okay, so it won't make it all the way up 1. It'll be shrunk because the amplitude is 1/2. So we've got a lot going on. Okay, so let's think about what it would look like. Normally, it's here, starts at 0, rises to 1 at pi over 2, and then down to the 0, and so forth, right? Okay, now let's translate those points. We're going to move up 3 and right pi, but only go half as high. Okay, so we're going to go up 3 and right pi. Okay, there's my new point. And now, for everything, I'm going to be just half as high. So instead of getting to 4, I'm only going to make it to 3.5 for my height. And then I'll be down to -2 or 2.5 for my height here. Okay, and then reverse it. Then nice smooth curve to connect the dots. Thank you. All right, we good with that one? And then I had to also, I messed up. I didn't move my shift, did I? Okay, so my apologies. So I moved up 3, and I only made it half as high, didn't I? But, and I actually did, okay? And then I said, okay, I have to shift it pi over. So instead of starting, normally we would start here and go this way. Okay? But now this has been shifted pi to the right. Okay? This guy's now here. This guy's now here. It's only half as high, so normally it would go up to 4. Okay? This would be a normal, so normally it would be, if I had just shifted it up 3 and right pi over 2, it would have looked like this. Okay? Would have came up here and down here. But now we're only half as high. So we're dealing with it having a max of 3.5 and a min of 2.5. It normally does. Okay? So we've shifted it to the right pi. Okay? So when we shift it to the right, okay, this is this new point. This is the pi to the right. A lot going on in that first problem. Okay? So if you want to do intermediates in between, by all means, but just make sure I know which one is your final. Okay? Yeah, I gave you a different, I have a different scale. I'm sorry. Yeah. Your sheet doesn't include this part. To save paper, and give you a bigger graph, I only gave you the 2 pi. Okay? Everybody good? All right, let's look at the next example. We're going to graph 1 minus 2 cosine x. So tell me how it's translated, shifted, and all that jazz. Okay, shifting up 1. Amplitude is making it larger, double in size. Yep. But it's negative, so reflect across the x-axis. Okay. All right, so cosine typically starts high at 1. It starts high, comes down, and does this. Okay, I'm going to stop at 2 pi since that's where your graph stops. I'll stop at negative 2 pi. Okay, so this is my typical cosine graph. And if it helps you to graph that and use dotted lines so you know that this isn't your final product. Okay, up 1 says translate everybody up 1. So this is what it would look like. Okay, but then it says to flip it and stretch it. Okay, so if we flip it, it's going to be reflected across the x-axis, isn't it? But the x-axis has now been translated up. Okay, so what was a positive 2 is now going to be down here at 0. Okay, so this is going to look like this. Because of that shift. Okay, without the shift, it would have been reflected across the x-axis, but now it's been shifted up 1, so now it's reflected across the 1. Okay, that's my new. Yep. Yep. Draw that dotted line. It's not an asymptote, it's a guideline. Now we've got to double it. Okay, so my final result is going to be the green thing doubled. Okay. Yep, let's talk about the green one. Okay, so the green one, all it's doing is it's taking blue. So blue we shifted up from red. Green we are reflecting across this line. Yep, so everything that was high becomes low. Anywhere they were on that green line, they're going to meet. And anything that was low becomes high. Okay. And then finally, we need to stretch this guy. So take the green guy and double everything. So when it was negative, or when it was 0, it's going to be down here at negative 1. And where it was at the new axis of symmetry here, it's going to stay. And where it was a positive 2, it's now going to be 3 because it's double that distance. here's our final line. Our final curve. Okay, can you see that colored pencils can be your friends with this one? Yes, sir. Okay, so you flipped it. Now all we have to do is stretch it. Okay, so instead of being here, it's going to be one more step away. One farther down, because we're doubling that distance. And instead of being here, it's going to be double the distance. Okay, double this distance. Double this distance. It stays on the line, yep. Because 2 times 0 is going to be still 0. Are we good? You're not moving. It does. It would have been just like the green line. If it was positive 2, it would be the green line, but stretched up. Okay. Well, yeah, it would blue line, but stretched up. You're right. Yes. Okay, let's put the phones away, please. Okay. All right, here we go. Next one. Okay. This is easier, right? Okay. This is just y equals, I should have put this in a different order, but this one is y equals 3 cosine of 3x. Okay. Actually, it's not. It's not the one that is 3 on the outside, so it's not going to stretch it. It's going to, yeah, it's going to change it within. Okay. So normally, cosine starts here, right? And goes here. So it goes like this. Okay, and I'm not going to put that rest of that on there because you don't have, it only goes to 2 pi on your sheet. Okay. Okay, but now instead of 1 here, it's 3, which means that you're going to get 3 times as many cosines in that same amount of time. Okay, it means that its period is going to be, instead of 2 pi, it'll be 2 pi over 3. In 2 pi over 3, you're going to get 1 full complete cosine instead of 2 pi. Okay. All right, so what this is going to look like is, get my note here so I don't mess it up. Still going to start high, but at 2 pi, sorry, at pi over 2, we will already be on our way up. Okay, it's going to shrink it horizontally because of the 3. It's going to make 3 complete cosine waves within the normal 2 pi. So it's shrinking it horizontally. Okay, so there's one of them. The second one is going to look like this. And here comes the third. Okay, so we have a complete That's how long it takes to make one full complete one. So this is the point 2 pi over 3. It's going to be basically every 2 pi over 3, you're going to have one complete. Well, you're taking your 0 to 2 pi and you're splitting it into threes. Okay? So we're going to split it into thirds. Find a better line here. Okay? So at 2 pi over 3, this is going to be one of them. Okay? Here's another one at 2 pi over 3 from there, and then finally at 2 pi. So it helps to change your scale. 4 is easier. I showed you one of the harder ones. Okay, so let's say it said the cosine of 4 pi or of 4x. Okay, that means that we're going to get 4 full cosine waves in the same time that we would normally get one. Okay, so every pi, okay, 2 pi over 4, every pi over 2, we're going to have a whole new wave. Okay, do we have an example like this? We don't. Okay, so let me show you it. Let's break out of here. So what you're doing is you're saying, okay, I normally have a point 1, 2, 3, 4 points that I worry about. Okay, now I need to take those 4 points and I need to divide them evenly into 2 pi over 3. Okay, because normally we complete a whole one in 2 pi, and we're going to be completing 3 of them in that 2 pi instead. Okay, 2 pi over whatever this guy is. Okay, and we're just sketching these. We don't have to be super precise. Okay, just a quick sketch. So let's look at y equals the cosine of 4x. Okay, get a new graph here. Make sure I'm not doing cosine of 4x. Okay, I'm not. Okay, so here comes y equals cosine 4x. Okay, cosine 4x says that we're going to get 4 cosine graphs in 2 pi. Okay, so we take the 2 pi divided by 4 and get pi over 2. Every pi over 2 will have one complete cycle. Okay, so nicely it has 4 little dots here, right? So we're starting high. We're going here, then here, then here, and then here. Okay, so one little itty-bitty compressed cosine wave, or period. Okay, our normal period would have been 2 pi. Now it's going to be a period of pi over 2. Okay, then we do it again. Da-da, 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 da-da. There's 2 of them, 3 of them, and 4 of them. And you do the same thing going backwards. Okay, so I purposely gave you a sine of 4x on your assignment so that you would practice that one. The 2/3, the thirds is harder. Okay. All right, here comes the next one. So if we had a cosine of 3x, and that meant that we had 3 complete iterations of our cosine in 2 pi, now how many are we going to get with sine of x over 2? a half. Okay, so our period is 2 pi over 1/2 or 4 pi. That means it's going to take us a full 4 pi in order to get a regular sine wave. Right, it's going to stretch it wider. Yep, yep. A whole number is going to shrink it, compress it, and a fraction is going to stretch it out horizontally. Okay? Yeah, it's only going to be part of a sine wave. Okay? Normally sine wave starts at 0, 0, right? And it would go high at 1 at pi over 2 and so forth. But we only get half of that wave. Okay? So if we're only getting half of that wave, then we've got to shrink this or stretch this out so that instead of being here, it's going to be here. We're only going to get this part of it in that 2 pi. Right, because that yours goes beyond, mine goes beyond. So I've stopped at 2 pi. Okay, so I stretched yours out. I should have done the same thing on mine. Okay, so now at 3 pi, here's 7 pi over 2, and here's 4 pi. So you're going to get a full complete one by there. Okay, need to make my PowerPoint match my note sheets. Okay, so what this is doing is it's stretching it out. Okay, normally we would have a full revolution, a full sine wave within 2 pi, but now we have to stretch it out. So basically you're skipping one. So skip one and away you go. Okay. Okay. So I'm starting at 0. I'll be high at pi, low or back to my intercept at 2 pi, low at 3 pi, and then back to where my intercept is at 4 pi. Okay. Everybody good? Okay. All right. Now let's deal with that negative that's out in front. Going to be reflected. Yep. We have not shifted it up, so our axis of symmetry has not changed. The x-axis is our axis of symmetry here. Okay. So now we're just going to go like so. And there's our final answer. Bless you. Bless you. Okay. And in some ways, these are easier than when you have the graph already given, the markings already given for you. So I'm going to give you some practice as we go along without anything, and you're going to draw your x and y axis and put your own markings on it. All right, so you've got a worksheet. Finish that for tonight or for tomorrow. Let you get started on number 1.